comparing cases in which we were able to have a situation where animals were in low abundance, in blue in the graphs below, and in natural relatively high abundance. And you can see that there's a number of plethora of ecological processes in which animals have a very significant role. Litter respiration and decomposition, carrion degradation, water quality and stream respiration, trampling, soil erosion and forage, carbon cycling, and so on and so forth. This, I would say, is an interesting, potentially interesting review, but at the same time, it's a kind of a naive view, because in this study, we just compare a given group of animals for an ecological process. But even so, you can see that this illustrates that animals, particularly ungulates, are relevant in a number of ecological processes. But it's not that the animals operate individually. The animals, the mammalian communities, are embedded or are inserted in a way, in a web, in a network of ecological interactions. So you can see here an illustration by a colleague of mine, Luisa Jenisch, trying to illustrate this phenomenon. The presence of these animals is not only the correlation of the ecosystem, but you can see that they have links to a number of other organisms, particularly plants in this case. This is the emphasis of this study. And you can see that these animals are not just the decoration. These animals that on top of the food chain are affecting these animals, and these animals are affecting a number of interactions with the rest of the plant life in this case. So we come to a situation that if we begin to lose animals, particularly medium and large sized animals, we are likely to eliminate all of these linkages that we had in the previous food chain. If we continue losing animals, obviously the disruption of these interactions brings about the extinction of ecological interactions. So the point that I've been trying to illustrate, the loss of populations, is not only the loss of populations per se, but it's also the loss of ecological interactions. If we continue further down in this trajectory, we will end up having a very depauperate food web of interactions, increasingly moving to changes in ecological processes and eventually leading to long-term changes in the structure of the forest with threats to these processes. So the ideas that you guys are going to be discussing these 2 days are very relevant in terms not only of the loss of these animals, but in terms of all of these changes that have to do with interactions and with ecological processes. In other words, restoration, refaunation, rewilding is critical to recompose or to reorganize or to bring back all of these interactions that we're losing in the systems. Let me illustrate one example from my own research to give you a little bit of a flavor as to the consequences, the cascade of consequences that come about when we begin to lose these gills of animals in our forests. I am going to illustrate the case of these 2 groups of animals because they are the focus of our discussion today and tomorrow, but also because they are known to play multiple roles. They are well known to be dispersers. That's the most famous interaction that they are well known for, but they also play the roles of folivores. As you can see, this animal is herbivorizing these plants here, and also they play a role as predators as well. They prey seeds and they attack and they damage seedlings and saplings. Imagine a situation like the ones that you know in your forest in South America, where these animals do all of these activities, and imagine the situation where you have big groups of these peccaries going through the forest understory and evidently creating situations that would be very different when they are not, compared to when they are not present. So let me use one example from my own research to illustrate this situation. My example has to do with this location in Southeast Mexico in the state of Veracruz. Unfortunately, in this area, which is quite relevant because it represents the northernmost point of distribution of the rainforest in the Americas, deforestation and fragmentation have been very dramatic. In this sequence of photographs of satellite images, you see in black the distribution of the forest in 1967, 76, 86, and year 2000. So what you can see here is a dramatic deforestation and fragmentation, which of course is inevitably bound to affect the animal population living there. We have been monitoring in this situation the occurrence of the animals, including the ungulates present in this place. And to make a long story short, this is an illustration of historical occurrence of these animals at this location. We have unequivocal evidence that these animals were present at some point. Unfortunately, I can confirm for you that all of these animals that have crossed have been locally extinct. And this is critical again. The species are present somewhere in the country or in Latin America, but locally in this place, they are lost. And for me, as an ecologist working in this location, the loss of these animals at this location represents a critical phenomenon to investigate. And let me show you what happens to the tropical understory when you have lost these animals. I'm going to ask the question about herbivory, the consumption of plant tissue and the trampling that these animals do when they are not in the forest. Excuse me, one of the mechanisms that we have been using to examine the situation is a typical analysis that we plant ecologists do. And I wanted to bring this because I think that when we contemplate restoration programs, reforestation programs, we also need to pay attention to the methodologies that we want to use to investigate the consequences on the plants. Here you have a bunch of plants that have been marked individually and also the leaves individually to estimate this thing that you see here, rate consumption, herbivory by vertebrates, by understory mammals. Here's a summary of all data that we published many years ago, and the data has been consistent over the years. On average, in a place that has been well conserved, that maintains the wildlife in the understory in good shape, such as this location, you see overall abundance of this process, herbivory, in about 27% of the plants and leaves. In a place that has been completely defoliated of these animals, that have been, in which these animals have been removed by the drivers that we saw just a couple of slides ago, you can see the extinction of this ecological process. So in this location, which is so important for the Mexican ecology, for the Mexican community, you can see that this process of herbivory, mammalian herbivory, is an extinct process. So not only the extinction of species at the local level, but also the local extinction of processes. Unfortunately, this situation is not only that phenomenon of the herbivory. You can imagine that the absence of these animals might have consequences that cascade into a number of phenomena beyond the herbivory per se. So let me illustrate that situation. In the understory of this location, this palm is very abundant. It goes by the name of chocho, by the common name of chocho. And as you can see, naturally, it's a very common plant in the understory. This plant is interesting because one can do very detailed demographic analysis of these species. Given the fact that the stems have these scars, and these scars represent the scars of the leaves that the tree produced, the palm produced, and if you know the rate of leaf production per year, you can actually estimate the age of the palms. So you can estimate the age of the palms by using these scars. You can estimate the fecundity of these palms because you can count the number of fruits produced. You can see the viability and success of those fruits when you look at the germination, and then you look at the establishment of seedlings, baby plants, the juvenile plants, then again, the adult plants. So you can do the projection, the demographic projection of this plant when the animals are not present in this location. And this is precisely what I want to show you. In the mid-1970s, when we began this study, we calculated the population demography to have a lambda of this species of 1.0. Essentially, the population was stable at that moment in terms of its population growth rate. We experienced the defaunation of this place, and by year 2012, a few decades after, the lambda had increased now by about 3% per year. So this species, in the absence of these animals, is increasing at an incredible rate of 3% per year. And this is relevant because this palm used to be, the fruits of this palm used to be the consumption of tapirs and peccaries and deer and so on. We lose those animals and those seeds now increase the demographic potential of this species. Those seeds that germinate no longer have the herbivores trampling and herbivorizing and doing predation on the seedlings and saplings, and therefore you're bound to explode the population in the absence of these animals. So you can see in this graph a vivid representation of the increase in the lambda. This is Astrocarium, 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 Astrocarium. You can see a dramatic proliferation of this plant species that is potentially very dominant, but it was kept at bay by the animals. In the absence of these animals, you see the increase of this species, and not only that. This has cascaded consequences on the plant community as a whole. For example, here you see that the density of this plant in different plots with different density, you can see that as you increase the density of the plant, in the absence of these animals, the density of stems of the other species declines significantly as well. The species richness, the number of species per plot, also declines in the species that this plant has become very abundant. And the diversity of the species in the understory as a whole also declines dramatically as the abundance of this chocho plant increases, or this Astrocarium plant increases. So losing the animals in this community, in this ecosystem, creates the hyperabundance of these species, which becomes dominant and which becomes the dominant and prevention factor of many of the species in the plant community. So in this location, which is very important, as I said, we are dramatically transforming the plant community as a consequence of the defaunation. So that tells you, I think, quite vividly that the restoration of these ecosystems is critical, not only because of the beautiful decoration that these animals represent here, but also because of the cascade of interactions that are being lost and the consequences that it has for the maintenance of the ecosystem as a whole and maintenance of the biodiversity as a whole. Let me move on to the wrap-up of my presentation today and bring another aspect here, that refaunation, for our plans of refaunation, we really need to pay attention to the habitat, the suitability of the habitat. And for this, we can think of a number of critical elements. For example, the area of the habitat, the conservation status of the habitat. So refaunation into a given location is not only to bring back the animals in given numbers, but also to examine what is the condition of the site where we're going to be introducing, or the condition of the site where we are collecting the animals from. One example to illustrate that situation here. This is again my study site in southern Veracruz in Mexico. And what you have here is this very, hypothetical situation of what would happen with the defaunation of this place. What I'm showing here is what is the area required to maintain a viable population of these species listed in the bottom of the slide. And for this, I am using the old genetics model of n equals 50. That is to say, let's assume that we need to have at least 50 animals of these species to maintain a genetically and ecologically and demographically viable population of these species. So on this axis, I'm showing the species, and they are organized in terms of body size, from the smallest, these heteromyid rodents, to the jaguars and tapirs on the right-hand side. And as you can see, for you to maintain the entire community of mammalian fauna here, you will need an area of roughly this size, 60,000 hectares at least, given what we know of these species in this location. If you lose area to this fraction, you're going to be losing all of this section of animals. At least the viable population of these animals will no longer continue to be viable. So the reduction of the area implies a reduction of the species. So for you to be able to maintain, if your target is to maintain the entire community of terrestrial mammals in the understory, the non-volant mammals, you will need to have this area. If you only have this area, you will be basically losing these species and, of course, the ecological processes that these species are involved in. So the example that I used in the previous slide of the transformation of the plant community is because of the absence, is due or related to the absence of animals in this category. So we need to pay attention to the area we want to do the refaunation process in terms of the habitat being suitable for them to maintain viable populations of the species that you want to do the restoration of. In addition to ecological aspects such as the area and the conservation status and so on, we also need to pay attention to the human and the social landscape. And this, as you can see, I try to underscore this very significantly, and the human and social landscape. If we do not have the local communities engaged and involved in this process of restoration, my experience is that usually these do not succeed. So in addition to the ecological and biological elements, we also need to pay attention to the social, ecological, the human social dimensions of the areas that we want to do a restoration. Let me do the last component of my presentation in terms of reviewing, thanks to this amazing work that Brazilian student in my lab, Luisa Jenes, which happens to be a student of some of the participants in this workshop today. She put together this amazing review synthesis of the current knowledge of the attempts that we have been made in terms of restoring plant-animal interactions in ecosystems around the globe. What Lisa did, she compared two categories of studies that have been published in the literature. Studies that have been attempted to do some habitat restoration, meaning essentially the restoration of the elements of the ecosystem in terms of the vegetation, typically, and also studies that have attempted to do what she calls trophic rewilding. That is to say, restoration in which you bring animals to restore the ecological trophic relationships. She looked at 4 groups of animals, mammals, birds, insects, and reptiles, and she examined the literature in terms of restoration and rewilding, considering 2 types of ecological interactions: seed dispersal, herbivory, pollination, seed predation, and some indirect effects. Indirect effects reflect at studies in which they try to do, for example, the restoration, and then by restoring vegetation, they indirectly restored the pollinators, which indirectly restored genetic aspects, for example. So those are the indirect effects that she examined in this amazing literature. Some highlights of what she discovered here. The number of studies is predominantly being conducted with mammals, followed by birds and insects and reptiles. But you can see that of the studies that have made an attempt to do some kind of restoration, all of them have to, the vast majority of them have to do with the restoration of the habitat, not directly targeted to the trophic rewilding, to the introduction of animals and restoring the ecological processes. So attempts that have been done to restore processes have been done as a consequence of most of the studies being done with the restoration of the vegetation, very or significantly less in terms of the restoration of the animals, in terms of the rewilding of the trophic interaction. And that low representation in the yellow case here, in the orange case here, is consistent across the different groups of animals, as you can see here. So this clearly shows our need to do more trophic rewilding, more rewilding of systems with trophic restoration in mind. Another interesting thing that she examined was the distribution of these studies, or these efforts around the globe. And as you can see, we're very lucky that a significant amount of studies have been done precisely in the Amazon, and to a very significant extent in Brazil, and also in the Atlantic forest. And is not no surprise that some of those studies, or many of those studies, have been done in temperate areas, as you see here in the US or in North America as a whole. But you can see tremendous gaps, for example, in the tropical rainforests of Africa, or dramatically so in Southeast Asia. If you were to superimpose on this map of lizards, you were to superimpose, for example, the map of hotspots of biological diversity, you could see some mismatches there, indicating that although some areas have been, luckily for us, have been studied in terms of restoration and rewilding of ecological processes, we still have tremendous gaps, particularly in some critical areas of the planet. Regarding...
Excuse me, Giso, you have 5 more minutes.
Yes, I will finish in 5 more minutes, promise, cross my heart. I promise.
Thank you.
Moving on to the types of interactions that that Lisa discovered, she noticed that most of the studies that have been done have to do with seed dispersal. So we're relatively okay in terms of studies on seed dispersal and restoration, particularly because of studies conducted in Brazil to a large extent. Much less in the studies that have to do with herbivory, much less in pollination, and even less in terms of seed predation, which is a very critical ecological process that we clearly have understudied. And in terms of the species that are involved in these interactions, here you can see that birds and mammals have been the main target of studies, particularly in seed dispersal. Moving on to a meta-analysis that she conducted, no time to go into the details of this, and in fact, no need to go into the details of this. On the panel A on the left-hand side, you can see that comparing restored sites versus reference sites, there's basically no statistical distinction between efforts comparing restored sites versus reference sites. Reference sites are the sites that have not been impacted at all, so it's no surprise that there is no clear significance there. Comparing, though, restored versus degraded sites, you can see that at least in the processes for which sample sizes were good, you can see that clearly restored sites did better than degraded sites in terms of these ecological processes. So restoration of wildlife with an emphasis on species interactions, on restoring trophic interactions, can actually have positive effects, as you can see here in this review. Okay, so this leads me to try and put together in bullet points some of the factors, some of the aspects that I tried to mention implicitly throughout this long and boring presentation. My apologies. And I want to summarize these 7 bullet points for you. We need to pay attention to the source of animals. Where do the animals are going to be brought back from? And of course, we need to address the situation of population variation. When we are attempting to do refaunation or restoration studies bringing animals back, population variation needs to be paid attention to. If we bring animals from a population in which they are very different to the location of the animals that used to be present in the location we want to introduce them, we need to be paying attention. That might be a factor that may determine the success or not of the effort. We need to pay attention in the second bullet point, of course, to quarantine efforts to make sure that we don't bring animals that might represent a risk of disease or spillovers of disease. We need to, as I mentioned, to be very careful about the suitability of the site that we are bringing the animals into, or the site where the animals are being brought from, particularly to be paying attention to the carrying capacity and to maintain viable populations. It would be very interesting, I suppose, to not to engage in massive projects before we do some pilot trials. We do some smaller scale trials to see if things are going to go well before we engage in the massive, extensive attempts to do reforestation. Both in those pilot trials and when we have already established the population that we want to introduce, we obviously want to keep on monitoring of the populations and the interactions and processes as to what extent they've been restored or not. Second to last, but not for that less important, we need to inform and engage the local communities that live in those places where we want to do the restoration processes. Because it is my experience that if we do not involve the local communities in the projects, if they do not embrace and engage in the projects, those tend to fail. And for that, we will need to accompany our reforestation efforts with education campaigns and follow-ups. We need to engage and develop programs of citizen science, and of course, to the extent possible, we need to employ the local people to be participants, full participants in the projects that we want to do the restoration of. And last but not least, I want to emphasize my point that reforestation is not only going to bring the beauty of the ecosystem that we used to have when these animals were present, but in so doing, we're also going to be restoring the ecological processes that functioning of ecosystems and we humanity ultimately depend on. And with this, I want to finish, and I want to thank you for your patience and your attention. Thank you so very much, Mariela.
Nós que agradecemos, professor.
Thanks to you, Professor. We don't have that much time for Q&A, unfortunately, but I would like to open the space anyways to see if there is any comment or question about the talk. Thank you once again, Rodolfo, for your participation. Your talks are always very relevant when it comes to this topic. And there are so many perspectives regarding the future, and looking into the past, we can realize that the prospects are not very good if we follow business as usual. Thank you.
With the rest of the program, so I can participate and come back to questions and comments if anybody has them.
Thank you so much.
Thank you very much.
Bom, então dando continuidade à nossa programação.
Very well, let's continue with the program then. We will now go to the second section of the workshop. Okay, now you can see me here. Hi, Rosanna.
The recording has
hand the floor
stopped.
to Rosanna, and then I'll hand the floor to Professor Fernando.
This meeting is being recorded.
And the questions will be addressed at the end of this block. Welcome, Rosanna. Do you want to share your screen? Do you want us to share it? I'm not sure you have the latest version, so I will be sharing my screen. Okay, I will let you know when you have 5 minutes left. I'll try to be very concise. Hold on a second, I'll share my screen.
Vocês veem? Vou já botar aqui no modo apresentação.
Can you see my screen? It's presentation mode now. Can you see it? Very well, thank you. Good afternoon, everyone. For those that don't know me, I'm Rosana Subira. I worked for many years at ICMBio following research projects, and now I am working at the CSE Brazil, a branch of the IUCN here in Brazil, in the state of Paraná. I work on the red list mainly, and also we have a task force working on translocation. So that's why I'm here to share with you some ideas. Following what Professor Rodolfo said, I'd like to say that we have an emergency in terms of biodiversity. Globally, the IUCN Red List has more than 35,000 species under extinction risk in some degree. This is 28%, almost 30% of all species that were assessed in terms of extinction risk. So this is a very scary picture. And conservation efforts, they are very intense nowadays all over the world. We have several tools to do that. The action plan that we are implementing now is one of these tools for planning and bringing people together to think about the problems faced by those species and think about solutions. There are many types of solutions, from interfering in the environment, setting standards, protecting areas, public policies, and so forth. There are several ways and paths to when it comes to preserving species that are under risk. And translocation is one of them. It's an option dedicated to conservation. I think we are all aware of how the IUCN works. We usually bring people, efforts, and experiences from all over the world together to come up with information and data, and also to recommend some guidelines. The IUCN designed, for instance, the guidelines for reintroduction, other conservation translocations, and action plans, how to design them. And when it comes to translocation, we have material recommending actions. These are the outputs that result from the work of many people from many places with very diverse experiences. And this is a dynamic process. It's constantly under review and construction. We are constantly enhancing and improving these initiatives. We have, for instance, this one, the guideline for reintroduction and other conservation translocations. And there are other examples, not from the IUCN, but with very similar principles. In Brazil, we are working on a proposal for a document tailored to the Brazilian reality. We are trying to come up with ideas and concepts thinking about the Brazilian reality. And thinking about your work in the next couple of days, I would like to share with you how we think about translocation for conservation. I don't know, maybe you're all aware of this definition, but it's worth remembering that it's good to keep this in mind when it comes to designing projects. So I'd like to start with this concept. When we think about translocation, generally, we are talking about the movement of living organisms made by human beings from one area to the other. These organisms can come from nature or ex situ. This can be intentional or accidental. Accidental, for example, those animals that come within ships or trade ships, and they are transported by humans accidentally, and they are introduced in a different location. This was not intentional. And translocation for conservation is when we move intentionally species and living beings from one place to another with the aim of generating benefits for the population, communities, or the ecosystem. So translocation for conservation is always intentional and has a clear goal of generating benefits for the population, communities, or ecosystems. There are 4 types of translocation. Translocation is a general term, but there are 4 types within 2 main types. First, the restoration of population in their native habitat, and there are 2 possibilities: reintroduction, when you release individuals within an area that is historically their habitat, or when you want to reestablish a viable population. So you have the aim of reestablishing that viable population, or you can have a different type, which is populational reinforcement or strengthening, when a population has reached a size that might make it non-viable in the future. So it's a very low number of specimens. So you want to really strengthen that population through translocation. The other types is an introduction. When you establish a population outside of their known geographical distribution, you are bringing this species to an area in which they did not occur beforehand naturally. You have 2 possibilities for that: assisted colonization. This is intentional translocation of an organism with the aim of safeguarding a population or species. This happens usually when you have their natural habitat compromised. Sometimes it no longer exists, or it is on the brink of compromise. So you need to help that species to colonize a new area because their original habitat is no longer viable for some reason. So you assist the colonization of that species in a new area. Or ecological replacement or substitution, where you found a new population outside of their geographical distribution with the aim of restoring an ecological process that was performed by a different species before that time. So the area lost a species, and now you are introducing a new species to perform the same functions and roles. So here the focus is not the species itself, but the environment that needs some sort of service provider there for an ecosystem function. So when we design a translocation program, you need to think about these 4 types of translocation: reintroduction, population strengthening, assisted colonization, or ecological substitution. So let's keep that in mind. Now, when it comes to decision making, I have to look at a group of species or environment that need our intervention because we're losing some a species, or there's a lot of human intervention. So I need to think about the tool that should be used for that situation, which is translocation for conservation. So I need to think very well about the situation first. I have to ask myself, is this the best option, or is there another option that could generate the same results? We need to take into account the benefits of that translocation, what I expect to achieve, repopulate the area, or that the species population will grow and be restored in that region, or I want to bring a benefit to that ecosystem that is now missing. So what is the benefit that I want to achieve? And what are the risks? What could this cause? Because there will be always some risk involved, and we need to assess how much we are willing to risk and how advisable it is to do something if there is a risk involved. And maybe think about other options, or to think that after all you have a risk, but knowingly go on with the translocation. So you need to be aware of that, because there is always some degree of risk. And before you make the decision, or before you translocate, you need to evaluate the alternatives. Are there ways of solving the ecological issue at hand, or improving the situation for that species that is less risky, that could generate the same benefit with less risks? Or maybe a less costly option, because translocation is usually very costly. So what are the alternatives? You need to think about that as well, because you are the one to decide. Maybe a species has disappeared because the approach was too fragmented and there are no pathways or corridors for them to reach the area. So how can you do that without translocation? Or maybe you should raise the awareness of people in that area so that you can bring hunting down, or maybe make humans more aware of the species and their presence. So any other alternative before you decide for translocation could be valuable. Of course, translocation can be an option. You can go on with it. However, you must keep in mind the other alternatives so that we can design a better translocation project. One IUCN recommendation and other guidelines include that too, is situations in which you should avoid translocation. For instance, when there are less costly and less risky options. After you think about all the options, you have maybe found better options economically or in terms of risk. So there is no need for a translocation to solve that ecological issue. The second aspect the second situation in which you should avoid translocation is places in which the main causes of population decline persist. For instance, maybe the population was extinguished because of hunting in that area, and this happened in less than 10 years, and the same communities are still there. So if I reintroduce the species, they will hunt them again. So if you did not solve the hunting problem, if there were no campaigns, and if I'm just giving hunting as an example, but there might be other factors that should be taken into account before you decide to translocate. So if the cause that led to extinction or to a very pronounced reduction is still there, if the problem still exists, introducing new individuals there will not solve the situation, because they will face the same fate in the end. Or when you detect a potential negative impact that is irreversible, or a long-term impact for other species or human populations. So it might be the case to avoid translocation. Also, when there are scarce human or financial resources, because translocation is a long-term strategy. So if you have enough resources earmarked for all stages, then you can go on with it. If not, you should first secure the resources before you start the process. Otherwise, you can run out of resources and not conclude the project. So financial and human resources scarcity is a reason for avoiding translocation. You need to have a clear idea of how much time this will take and how much it will cost. And one last case, a very common situation, is when the focus is solving problems of ex situ surplus. You have an ex situ species that has reproduced exaggerately, and now you want to solve that problem. So you need to be careful with that. It's not that ex situ excess cannot be used. You can use it if you see that the species need populational strengthening, and you have a very strong ex situ accident. And if you want to repopulate that area and you can use an ex situ accident, then you can do that. The problem is not needing in terms of species or the environment, but you have an ex situ accident problem and you need to do translocation to solve that. So this is a more controversial point, but it is a reality nevertheless of the wrong type of motivation for translocation projects. Now, if there is a species that I know has gone extinct in an area, and we think about reintroducing that species there, and if there is an ex situ accident, I will experiment. And this is part of the possible actions. I experiment with translocation for a species because I have an accident and I need to repopulate that area. So I will take that risk, and I will, because I have a surplus of species that allows me to do that. So usually when the starting point is an ex situ surplus, you can do that as long as an area needs that kind of assistance. Now, when it comes to planning, you have 4 pillars that I'd like to address. Usually, when we design a project, we think a lot about planning the translocation project. And there we include everything: the objective, the area where the species will be released, the reason for the translocation, and then I decide what my source population will be, if I will remove from a different area or if I'm going to use the ex situ surplus. I think about the social impact, execution, the release itself, the monitoring after they are released, the success criteria. So I think about everything and I set up a very well-designed project.
Everything within planning. So I need to think of these three issues. So viability assessment. So this project that I'm thinking of, all the actions that I'm going to perform to do translocation, is it viable? And here, from all possibilities, socially, ecologically, financially, do I have the resources to be able to, pay for this project? Am I going to have any legal problem, any social problem? Is it legally viable? Is there any kind of legal restriction that does not allow me to do this movement of taking the species to a certain location? So think about everything that you're going to consider as far as project viability. Do I have all knowledge, basic knowledge? Do I know the species enough? Do I know the environment enough? Do I know what might actually happen when, I take the species there? So there is this sort of, following on, but I am very much aware of the gaps, or I may just come to the conclusion that I haven't really got enough basic knowledge. I do not know my species interaction with other 2-3 endangered species which are part of that region. I don't know how they're going to behave, so I'm not going to risk the other species because of mine. Saving one, I end up kind of hindering the other. So maybe your solution could be delay the project, review all of this, and then you wait to do the translocation when you have the hard data, for example, Or you could come to the conclusion and say, no, look, I know enough. The knowledge that I've got is enough. Thus, we are moving forward. So these things that I'm basically presenting is for you to have a checklist, for you to be aware of what you're doing so that you're not caught, off guard with any problems sort of further down the line because, you didn't think of this, because the recommendations, they are always, be sure, you have health-related issues. Do I know all the pathogens that affect my species? For instance, is it viable despite knowing that we have something which is quite normal for the species to have? And then do I have to look at all the pathogens of, the population I'm going to release, could take, but what kind of impact is it going to have there? So we need to look at all viability issues. And then another point is risk analysis, because all uncertainties, a lot of things could happen that you don't know. I mean, ecological risks, the disease, as we were saying, so the disease that I could take, back, we have invasion risk. I mean, is there the sort of track record of the species being an invaders in other areas, other congeries? Also, is this a risk? Is this risk an acceptable risk, or does it actually, not make releasing the species algal something actually viable? So I don't know, I'm releasing a predator that could lead to all sorts of ecological problems. It could also have a problem as far as the human community. Do I have that information? We have seen cases where, species were released, and then there's individuals, they leave the protected areas, they go to farms, for instance, where they find food easier. Are we ready for running this risk? And this is a risk that stops me from doing my translocation, or is this a risk that I'm going to, take on because I already have the solutions kind of set in place to solve all of these problems? Okay, so we always need to think about this. We need to kind of really predict what could actually go wrong. This is the idea of it is. And then finally, you need to have an exit strategy in mind, okay, for many situations. So, everything worked out. Your project, ran as you expected. You had one or two little hiccups here or there, but, it all ran smoothly. So how long are you going to monitor the species? Are you going to be in this project? You're going to be out in the field working, with people, working with the communities around the region. So when are you going to leave, if you will, to exit the project, if you will? For how long? This period could take a long time, and this could mean a high financial cost. And what about if it didn't work out? It was wrong. It didn't happen as I predicted. So before starting, you need to have your exit strategy very much clear in mind, because in addition of not meeting the expectations as far as results were concerned, it really went proper pear-shaped, you know what I mean? Did not work at all. The species went much further than we expected. They left an area. They went much, much further than I predicted. They migrated to another region, another area, and they are basically creating problems in this other area. I need to have an exit strategy. An exit strategy could be, collecting back the animals that you've released because they've invaded, the neighbor's plantation. You're having all sorts of problems. It didn't work out. Then you need to collect the animals back. I mean, this is all something that's going to have a social, financial cost. You need to be ready for that. So when we do the planning, you need to consider all these possibilities. Okay, so we run a risk analysis and a viability analysis, thinking about everything that could happen. Okay, so we ask, the question, what about this? Do I know anything about this? Can this go wrong? And if it goes wrong, what do I do? What am I planning to do if this goes wrong? So it's important. I mean, the guide helps us to think because it has a lot of recommendations, but it helps us to build and to think about all the questions that we need to ask. Not that you need to ask, but that you should really ask to have very sort of safe, coherent planning, even if you do know that there are all sorts of gaps here. So I don't know what might happen here, but I am aware of this. So there are a number of risks that can actually happen. I don't know to what level, but I have thought about this. I have kind of tried to forecast this. This is not going to catch me off guard. And I, had thought about what I would do if this does indeed happen. And then, of course, we always are going to have the sort of unpredictability factor because, something may happen that you don't remember. But then if you try and cover all possibilities and you're safe about this project, you're certain about this project before you start, because when you start analyzing this, you may come to the conclusion that, actually, let's delay a little bit because I need to know more about this and that, or we have another path which is much more viable, is going to solve the ecological problem, the species problem, going through a less riskier path than going straight into translocation, for example. So the idea is that translocation is a tool, okay, for conservation, which is being used ever more. And we see more and more successful examples, the success stories as far as translocation is concerned. But we always mention that the failure cases, they're not published, because we think, look at this, so beautiful, such a beautiful species. But we also need to, publish when things go wrong for us to be able to, swap experiences, because we need to learn from our mistakes, because this happens a lot, okay? 5 minutes. Rosanna, yes, okay, thank you. So it happens, what I mean? You try and do something goes wrong, or something that you hadn't really planned for, or you forgot to predict something, or you didn't do appropriate planning and it didn't work. You know what I mean? It didn't go well. So I think that publishing unsuccessful cases is very important for us to be able to share these experiments, these attempts, if you will, So a last thing that I like to mention is that when we think, okay, so this has worked out, everything that we wanted to do, the intention of repopulating or strengthening that population, it all worked out. And then to check the success, this takes a while, because we have a time curve, which is 3 phases. So we have, the establishment phase, the growth phase, and the regulation phase of the, population that you're translocating, that you're introducing to a different area. So first you establish and then you see growth, but the individuals, they're still, adapting to the novel environment, they're still trying to find a reproductive partner. So it's all that sort of starting phase, for establishing. And if this does indeed work out, we're going to have a growth phase, and then you have to start regulating, because there are a number of external factors that come into this sort of regulation, and then you have to contain the growth and whatnot, but this is all part of the game. But how long does it take? Well, it depends on your species, so it depends on many different things. So when you start on a translocation program, be ready for this. Up to when are you going to follow up this, population? How long are you going to monitor, study the individuals that you've released? Okay, they've started growing. Do you consider that it's established? It starts growing, so now I can kind of take a step back, or do I need to follow all the process? And the reason I say this, okay, is because everything has a financial cost, and you need to be ready, for the sort of long-term costs, because you're going to have to be in project, in the long term. So for example, I did a translocation, it was successful, the population has established, they are now regulated already. And I think, yeah, basically this is what I had. I wanted to, bring some food for thought, things that we need to keep in mind in order for us to have a very well planned translocation project program, thinking about conservation. I think I really spoke fast because of time restrictions, but hey, thank you very much. Thank you, Rosanna. Thank you very much. It's very important, the concepts that you have shared with us, for us to be able to talk, in the same language, bringing this role of planning to the project. This is very important. Thank you. I think someone had their hand up. I'm not sure if I saw that. No, I didn't see any. Yes. Yes, I have my hand up. Can you hear me? Thank you for your presentation. I think you know me, but I'm going to introduce myself very quickly. Yeah, his audio is really, really low. We're going to do our best here, okay? So we have the sustainable use of animals. We do a lot of research with tapir and something that we've been thinking about as far as a protocol is concerned that you prepared. It seems to me that something that we can do is do nothing, Yeah, I work with white-lipped peccaries too, but now we try and do this in a certain way, everything which is a risk. I mean, in ecology, there's always risk, there are always big risks. And the way that Professor Disso presented to us the risk that we are seeing in mammals, this is very, very big. But now when we talk about risk, you yourself were talking about risk analysis, Professor Disso presented that everything is a risk, and then risks are big. And if you do not face the risks, then the protocol will only keep status quo, and is not going to change the current situation. Yes, sorry, Professor. No. I'm sorry if I gave you that impression of the idea. is to make you think about all elements, okay? Is for you to think of everything that could happen, for you to be aware of what may happen. Is because when you measure risk, it's difficult, right? Measuring the risk, you know that there is a risk of whatever, but it's difficult for you to know if it's a high risk, if it's a low risk. So unless it's something very clear, like this risk is very high, for example, I think that the best decision would be not to do this, but it is difficult for us to, make this decision if this risk is enough, because the idea is not for you to give up, it's for you to have in mind the problems that you may face when you're implementing the program, for example, because the idea is to do the translocation, but be aware of what may happen, and you're learning with this also, because you need to record what, may perhaps go wrong, because a lot could go wrong. And this is something that kind of gets away from you in the first moment when you're planning. So the idea is to think of everything that could happen so that you do not start the work unprepared. Professor Carlos, I'm sorry, everyone, to interrupt the conversation, but we had planned questions and answers for after Professor Fernandez's presentation. So I'd like to ask Professor Carlos to write his comment or his question here on the chat function. And then we'll leave this for the end of the other presentation. I do apologize for interrupting, but it's just not planned for now. So thank you, Rosanna. If you do have any questions or anyone has any comments, please, I'll ask you to leave that on the chat function. Okay, and now I invite Professor Fernando Fernandez. Please introduce yourself. Do you want me to share your presentation, or can you do it? I would prefer you share it, okay, because I find it easier, because I get a bit confused with all of this, and then I'll just say next, and then you go on to the next slide. I'm just going to open it up here, okay, and then we'll just make sure it's the right presentation and all that. And then you guys let me know if you can see my screen. Okay, Fernando. There was this slide. We had to convert it into PDF, okay, to be able to download it. And there is a slide in a presentation which is blackened out, which I believe it's a video. It's a video. Do you have a link for the video for us to be able to maybe show it after? I can share my presentation and share from my presentation if you want. I mean, let me just have a look, see what I've got here just to go through. Okay, just a second, please.
Mariela, a apresentação está em tela cheia.
Mariela, can you see the presentation? Yes, thank you, Marcelo. And then I try and share the presentation, and then we can go from my presentation if that's okay. Because if not, we'll just leave it. Okay, let's see if it works. Okay, so this is in full screen for everyone. Can everyone see? Yeah. So good afternoon, everyone. Before anything else, I'd like to thank you for your for the invitation, and also thank the two previous presentations from Rodolfo, from Rosanna. They have made my life much easier. So I'd just like to present to you a possible dream, which is the reformation or the rewilding of the National Tijuca Park. So I'd like to start this presentation mentioning an author who I really enjoy, Montenegro, 1980. Next slide, please. Right, so he's singing his lyrics to a song, okay? If today you do not find weird to see something cruel, or, fishless lakes in an empty room, I do apologize. Hug me, my son. I do not know if I've tried as much as I could, okay? So this is our theme, okay? So here we have, a slide about the empty forest, which was a concept released by Redford in '92, and I had the privilege because Rodolfo addressed this very much so. And then, he used a more modern term, which is defaunation. And well, I'm not going to really go into what he showed you, but basically speaking is, having these forests that we have today in a lot of, the tropics in different parts of the world, forests where you do not have the big animals anymore, and forests where you have piles and piles of fruit rotting on the ground, which shows that the, animals that play the ecological part of dispersing these fruit, they are no longer in the forest. And this is the signature, if you will, this empty forest, rotting fruit piles on the ground. And Rodolfo showed this very well. This is very much a reality, this lack of big animals in the forest, which is something that we see. This is an artificial condition, and this is something that affects the workings of ecosystems as a whole. So this comes from Carolina Bello and all. This is a work that I've taken from that. The image has a small defect there, but on the first sort of image, you have all of the ecological interactions, which is then lost. And then when you have a defawned forest, if you will, you also lose the ecological interactions, and the ecosystem is no longer functional. And then these ecological interactions, they are responsible for the reproduction of most trees, in a mature forest, for example. So many things such as plant reproduction, pollinization, populational reproduction, nutrients and all that, things like that no longer work in the ecosystem, which is the consequence of defaunation. Now, a way of actually looking at this problem, trying to address it, as it has been shown, this is a gigantic global problem. A way of trying to deal with this is to introduce populations to this empty forest, bring life back to these empty forests. And Rosanna has talked about all the different types of translocation, which is an intentional movement of animals by us. And one of the cases, as she mentioned, was the reintroduction. In other words, reintroducing a population of a certain species in an area which was part of its original geographic distribution for that species, where that species was locally extinct. So it is the reintroduction of populations, native populations. And this is a tool which is being used ever more in conservation. When we talk about reintroduction of native species, it's kind of redundant, really, because Rosanna also talked about introduction being used in conservation. But here we're talking about the reintroduction of native species, because this is a tool which is being used ever and ever more. But now we propose a sort of step forward, even, a step beyond, really. In 2010, my former PhD student, Luis Gustavo Oliveira Santos, and I, in the Conservation Biology, a magazine, we proposed the idea of this refaunation, this rewilding, where we criticize some ideas, which is this concept, a much wider concept, particularly rewilding as far as North America is concerned, in the late Pleistocene, a little over 10,000 years ago, because we thought that this made a little bit more sense in the conservation agenda for the 21st century. In the article, we gave a name to this idea of rewilding. So we refer to it as refaunation. So this is Gustavo. Okay, so by refaunation, what we mean is the restoration of entire faunas, not through the reintroduction of single species, but through the reintroduction of sets of native species to ecosystems from which they have been extirpated. So here we're talking about the reintroduction of sets of native species to rebuild a local, original fauna to the extent possible to reintroduce them. And of course, we, in many places, do not hope to reintroduce those species and reproduce, if you will, all of the native fauna, because you don't even have area available for all of them anymore. But you can, up to a certain extent, rebuild a lot of the faunas, a lot of the interactions, and through a much cheaper process, which would be this sort of crazy thing of, trying to just rebuild all the Anthropocene, but we have some other species which are waiting to be reintroductions, and we have interactions which are going to evolve with the species that you are introducing this refaunation. And in literature, refaunation is being used as a synonym of trophic widening. In other words, you use this to rebuild this trophic relations, because you rebuild to the extent possible native faunas, allowing to rebuild ecological interactions that we had in that place to the extent possible, of course. So when you rebuild these interactions, you start placing the species back in the forest. So you revert defaunation through refaunation, as Rodolfo mentioned very well. So with this, you restore the interactions, you rebuild the whole functioning of the ecosystem. So reverting defaunation through refaunation or rewilding. And then a paper from 2017, Mauro Galetti, Alexandre Pires, Pedro Brancalion, and myself proposed some candidates for refawning, if you will, of the Atlantic forest. So here we are talking about species that play important ecological roles, species, conditions, criteria that we considered for these species to be important candidates for refaunation. So native species, of course, that we had stock, being built, being raised, that had the possibility of bringing these processes back, and species that has been pointed out, japutinga, tortoise, cuchias, tapirs, cotetos. So we've not actually pointed out the white-lipped peccaries, because there is the possibility of a conflict. We know that this would be wished, but we haven't got, enough of these animals to bring in. So in the case of our refaunation sort of process for the Tijuca Park, we did a workshop in the Tijuca National Park also, where we have invited many different experts and people from the park to discuss what would be possible for us to do as far as reintroducing species, and of course we need the stock in captivity and all that. So with these ideas, we started really refaunation project of the National Tijuca Park that started in 2010. So in addition to me, we had some other people involved in the field, in the sort of day-to-day activities of the project. And then this process started in 2010 with the first species being reintroduced in the park, which was the agouti. And they had been extinct around 40 years in the park, and they are very good at dispersing these elements, and they are something that come in through different seeds in adequate situations. So they are very good and many of them came from the Santana Field, which is an urban park in Rio de Janeiro. 31 individuals were reintroduced, and we also have another population existing in Laje Park, but when we started was 31 individuals. Next.
So they were reintroduced and acclimated, being released in the Tijuca forest with food and a fence for their acclimation. And there's no standards, but there are some criteria on in the literature for the short-term success. And these would be survival without supplementation, the establishment of life areas, and the reproduction in nature. The picture that you're looking at is a landmark in the project. It's the first agouti offspring after years of extinction. So this shows the short-term success of this agouti reintroduction. You can assess the short-term success by monitoring the population after it's been reintroduced for a longer period. They are captured and photographed. And after several years of monitoring, the CENAP et al. Article in 2008 published data. At that time, there were 35 individuals. And what is most important, they were all born in nature, which shows a self-sufficient population in the achievement of a self-sufficient agouti population in the Tijuca National Park. The second species were the howler monkeys, the Lactaguariba. This is Luisa Genes. She was mentioned in Rodolfo's presentation. She's now reading her doctorate with Rodolfo. And the howler monkeys, they are primates that have an important role in dispersing seeds, together with the agouti. They have been present in the Tijuca National Park for more than 100 years, and they are folivores, herbivores, and they are very present in that area. So we started to reintroduce the species. 12 individuals have been recorded in the national park. It's not an easy process. We had some problems in the case of the howler monkeys. It was harder than the agoutis. They were overly dependent on people that fed them. Some of them had to be removed so that they were not run over by cars, and also because they were no longer part of their population and were not participated in seed dispersion. And also we had a problem with yellow fever in this species. So some institutions and agencies instructed us to stop the introduction of animals. So we have today, after some mortality, only 7 howler monkeys, a couple, Kala and Juvenal, a youngster, Tupi, and 4 small monkeys, or the Kala's offspring. And other 7, I believe, I think Marcelo has the more precise figure, because he is following up the interaction of the second group of monkeys that will be released, the third group that will be released, and they will be released in 2022. So 7 additional monkeys, and they are now vaccinated against yellow fever. And then we think that this can be a game changer to reintroduce vaccinated specimens against yellow fever. So with that, we think that the number of howler monkeys might increase. And the third was the introduction of the Jabutitinga tortoise. So the Chelonoides denticulatus, the reintroduction was carried out by my master's student, as well as just like what Luisa did before. This is Carolina Stalin, and 50 specimens were released in Tijuca in 2020-2021, according to a experimental design. They were released both in the rainy and the dry season, and 38 of them are still alive. There is reproduction already. There are eggs laid, and the reproduction is more recent, but it seems to be on the right track. So there has been restoration of ecological interactions, which was the main goal. One of the things that we mentioned in the past when we proposed refaunation, to restore ecological interactions, several of them through several species playing their parts in the ecosystem. In the case, the agoutis were seen interacting with at least 40 species, and howler monkeys with at least 60 species, according to these graphs. And some species, for example, the Erie palm tree, the Astrocarium oculatissimum, the Cutiera Joannesia princeps, that germinated successfully after the arrival of the agouti. So before that, there were no germination of this species, what we called a living dead forest, adult specimens of a vegetable species, but there is no plants germinating. So they are doomed because there is no adult replacement. But now, at least for these two species, there is a recovered recruitment in the areas where the agoutis were reintroduced. This shows the restoration of ecological interactions. An important step was that in September last year, September 2021, the Refauna Association was founded, an NGO dedicated to refaunation projects, reintroducing native species to reconstruct the population in the forest. An NGO specialized in refaunation. It's not a general purpose NGO, but only dedicated to the reconstruction of fauna and ecological interactions. So it's the Refauna Association. Here we have several members of the board present. Marcelo Rengens, he's the executive director. Marom Garnier, also member of the board. Myself, the currently president director. So Refauna will allow us to expand our scope, and we will be carrying out projects not only from the lab and doing research, but also through projects that can be led by teams and that can have more access to international funds, and that can also include more participants outside of academia. And we hope this will grow significantly and do more. So please stay tuned in our social media channels. We are a young association and we need your support. And working together, we can do much more and really plant the seeds. Excuse me for the pun, but to really plant the seeds of refaunation so that the project in the Tijuca National Park can be replicated elsewhere. So the following step, the fourth step of Refauna, will be introducing the Araraúna, the Canindé macaw, that is planned for 2023. Next. So Rosanna's presentation was very interesting and important because she's well said that this is a very complicated work, a very complex work that needs to take many aspects into account, as she said. And there are risks also, things that can go wrong, and you need to be prepared for when they do. The projects in the refaunation can be reversed, and you can do many things that you didn't originally plan for. You have to deal with the root cause, the extinction root cause removal, and really to deal with species in captivity, and people is usually a complicating factor. So we should not delude ourselves or deceive ourselves about the reality of this goal, because it's not an easy task. And reintroduction is a difficult task, and refaunation as well, but the results are wonderful. I would like to share my screen. Here I'm saying that I cannot share my screen if another participant is already sharing the screen. So please, if you can, so I can share my screen, please. Can you see? Can you all see my presentation? Yes, we can see the PowerPoint slide. Yeah, the one before the wildcat slide, right? I wanted to show you a very brief video so you can have an idea of what the key refaunation moment looks like. Fernando, we're still looking at the PowerPoint slide.
Sendo mostrada como uma
Yes,
apresentação.
we only see the PowerPoint screen, not the video. Okay, let me try again.
Ainda é a tela do PowerPoint, mas agora é um slide preto.
Slide preto.
We're still looking at the PowerPoint slide, an all black slide now on the screen.
Oh, wow.
Fernando, põe em modo apresentação, aí ele deve aparecer a setinha.
Eu tô botando aqui em modo
They're just giving instructions to Fernando so that we can he can share the video.
eu já pus em modo.
We still can't see anything.
Leitura, que acho que o modo leitura às vezes funciona quando o modo apresentação não funciona. Vê se vocês estão vendo agora.
Sim.
Estão vendo agora?
Agora
Sim.
sim. We can now see the wildcat slide. Yeah. Okay, I wanted to show a video to you. It's a 2-minute video.
Beleza.
Fauna reintroduction project. There's no sound, unfortunately.
Não.
The howler monkey release. That's what we saw on the slide.
Fernando, para que o som saia na apresentação, você tem que, por gentileza, para
Is giving sound sharing instructions now.
novamente, e na parte, quando ele abrir a parte de compartilhamento, ele vai ter uma frase embaixo, share sound, para você poder compartilhar também o áudio da apresentação, por gentileza. Só um instante. Deixa eu recuar aqui no PowerPoint, beleza. Aí, compartilhar de novo. Share sound, beleza, perfeito. Maravilha, agora sim. Vê se agora está certo com imagem e som.
Perfeito.
Perfeito?
Okay, now it's working. So the release of howler monkeys.
Bruno, Carole, alunos nossos.
Bruno and Caroli, these are some of our students. Liana. Now the moment of release.
Aí vocês têm momento em que Kala.
Here you can see the moment in which Kala, the mother of the 5 offspring, becomes the first howler monkey female after 100 years of extinction.
Colar de rádio, né, para monitoramento.
The radio collar. For monitoring.
A equipe, o Marcelo Rengans.
Here's our team: Marcelo Rengans, Luisa, Katusha, Sylvia, Bruno, Liana, Ernesto, and everyone you see on the list. So I wanted to finish by saying that despite all hardships that we know exist, refaunation seems to be a possible dream. As such, it can help to bring back the hope that we need, that we so much need, giving us a positive agenda for the 21st century conservation. It can help us to feel that in such a key moment for the planet, we are, yes, doing all that we can. Thank you very much.
Muito obrigada a você. Nossa Senhora.
Well, thank you, Fernando. It really fills us with hope looking at these scenes, the first female howler monkey after 100 years in the Tijuca National Park. So thank you, Fernando. Thank you very much. Now, we want to open the floor for questions or comments. If you want to say anything, you can write on the chat box or turn on your microphones. I want to read what Rui said on the chat, saying that he agrees with Professor Fragoso in the sense that we tend to have precaution when it comes to the risks, because they are accentuated sometimes, and we tend to know more about the risks than the benefits, and we tend to make decisions based on what we can lose and less on what we can win. So the risk assessment of an action must be compared with the risk of not doing anything. So I think this is a very well balanced, these are very well balanced presentations. What Rosana said about taking everything into account and the hope of really doing something and restoring ecosystem functions through defaunation, as Fernando presented. I would like also to say, Mariela, that when we perform risk assessments, it's not only about writing a list of problems, of potential problems, because we can go crazy, because we are very good in identifying problems and only potential problems, not only and not necessarily likely problems, because the status quo of not doing anything also pose problems. So we need to compare action with non-action. Last week, we were working with a reintroduction of a species, and we had a long list of problems, and some of them that I can state as a question. Every time we put different populations together, people talk about exogamic depression. And this is always mentioned for all species in all meetings, exogamic depression. But we need to ask ourselves, is it a real risk? When is exogamic depression a real problem? So we need to really think about these problems. And this and thinking about problems can really freeze all action. So what I'm trying to do is to really propose a more positive narrative so that we can be more than just people who identify problems. We have Ronaldo and Rosana with their hands up. Please go ahead, Ronaldo. Yes, my question goes to Professor Fernandez. Congratulations first for the work. I'm a big fan of what you are doing. And now, along the lines of what Carlos Reis said, I ask you, what is the estimated cost of reintroducing the species that you have introduced? And do you have any estimation regarding the benefits of these reintroductions? And can we state these benefits clearly in order to show decision makers how valuable these actions are, and maybe obtain some funds to carry on with these initiatives? Yes, Ronaldo, we need to work on estimations, cost estimations. But when Kenupi wrote his article for the agouti reintroductions, a cost estimation was developed, and I apologize, I should know it by heart, but I don't have the figures right now. Maybe Marcelo remembers, but it was very cheap, actually. Reintroducing agoutis was not costly at all compared to other species. Other species can be more expensive, but this is an interesting work, developing these estimations. And recently, last Saturday, Carlos Eduardo Young came to me. He's an ecology economist, and he proposed a work together with us to estimate the cost of all these reintroduction and refaunation initiatives. And this is very important for management, of course. Now, the benefits, we can think about economic benefits of conserved ecosystems and the role they play in preserving water and pollination and ecotourism. So there are many potential benefits, but I think that more than economic benefits, we need to think about biodiversity.
Eu concordo pouco com o Carlos Ruiz.
I agree with Carlos
Não fazer nada, né?
that there is a high cost of not doing anything. Of course, there are risks, and we need to think about them very carefully, and we need to really back down from ideas if we think they are not going to be successful. We need to be open to that as well. Now, we are living a moment in terms of biodiversity that we see all species and ecosystems really melting before our eyes. We are losing things very quickly. So we need to do things to mitigate and to reverse these process very quickly, of course, with safety, with all the knowledge that we can gather, that it's far from perfect, but enough knowledge to carry out actions in an urgent manner, because we are living a very critical and decisive moment for the history of the planet. And this affects everyone, society, our economy, the quality of our lives, our future, and the planet that we'll be leaving for our children. Go ahead, Rosanna. Yes, Fernando really said everything. First, I'd like to congratulate you for the work you do in Tijuca. It is an example of things that work well. And I'd like to second what Professor Carlos said, that the risk of not doing anything is very high, and we need to ponder on that. And what Fernando said is important. We need to be careful, and we need to be aware of the risks, and to be careful, of course, and be aware that we need to not doing some of the actions that we want, but we need to be brave and sometimes bold. We have translocation projects in Africa, for instance, which are examples of great mammals, and they are very courageous and they are very bold. But they calculate the risks very well, and they carry out the projects knowing about the risks. So we really need to balance things, seeing how much precaution is needed and how much risk there is, and really know what to do. The key issue is to think things well beforehand to avoid any unpleasant surprises. José Luis, please go ahead. Hi, Fernando. I have two questions. One, I believe that in Tijuca, there are domesticated species like dogs and cats. So do you have any idea of the impact of pets on this fauna that you want to reintroduce? And the second question regarding risk, I often see what Edward Wilson said, man first. We sometimes risk not doing anything because of our own species, to trying to avoid disturbances to human groups. We need to understand, of course, the communities that will be impacted by the reintroduction of an animal species that could impact them more. But we need also to find strategies to really be bold and brave, as Rosanna said, because there will always be people who feel disturbed or who are bothered by reintroduced animals. People sometimes are bothered by conservation units, but after all, that's the main goal of conservation units. Is to really preserve species and keep them alive. But we sometimes think, well, but you might disturb the neighbors. And well, that's just life, and you need to think about that as part of the project. This cannot be something that will refrain us from taking action.
Yes, there is. Unfortunately, I cannot watch your lecture because unfortunately that's right when I pick up my kids from school, so I do apologize. I know, but I know you, unfortunately, I'm going to miss out on that. But yes, we have a big focus on us, right, on our sort of species in our own problems, and then this favors this inaction from our side of things, but we need to take these risks, into consideration to the best of our abilities, but but we also need to do our part, because all the other parts, they're quite destroying. Okay, and you have a question, Fernando, right? Yeah, you have a question about the domestic animals. No, yeah, it's a great question, actually. No, we did have a problem, particularly with Akuti and domesticated dogs. Tijuca, it's a very transformed environment. There are some exotic species, animals and plants, but they have domesticated species too. So you have a community of rodents, which is dominated by a philanthropic rat associated to humans. Okay, and there's a problem there, which is serious, with dogs. So we had some interactions, some attacks, by dogs, and we did study the problem. I supervised an MA thesis from one of the park's employees on the dogs, but it was interesting because we concluded that there is no population of feral dogs in the National Tijuca Park, because we never saw a pup, we never saw any reproduction. But apparently what we do have is adult individuals that you have in that apparently they come from houses in the region. So you have, dogs that come over, I don't know, spend the day, if you will, or spend part of their days in the forest, and then they go back to the houses where, they're based, sort of thing. So we estimated the size of this dog population in all the different moments in the park. So we're looking at about 30 dogs, and we did that through photo traps. And then we have methods where we identified each dog individually. Okay, so this is a relatively low number. So yeah, there is a problem. And I think some other national parks also, for example, in Brasília, you have more serious problems with that. I think it's worse than here in Rio. But you also have cats, domesticated cats. We don't really know the impact of that as much. But I do think that this is a very big underestimated conservation problem, because we think it's a small problem, but no, they're not. I mean, domesticated animals are in most conservation units, and a lot of the times they do leave a lot of damage for us. Was a problem, fortunately not a huge problem, at least not until now. Okay, we have 2 more minutes. Okay, so I'm going to ask you to be brief, and then we're going to finish the Q&A session after your question and your answer. Okay, Babante, yes, thank you, Mario. First, I'd like to congratulate the 3 amazing presentations, okay? which may serve as a base for us to discuss the future of this strategy. But at the moment, I'd like to support Rosanna's sort of discourse. I really did enjoy her presentation because she really, balanced out the risks very clearly, because there is a trend by people of, having the sort of release process, seeing it as the solution to the problem. And a lot of the times it brings problems, not always is the solution to all problems. And in Brazil, we do have a tendency for this, where we have projects where the scientific part is rather poor. That is, to solve, let's say, problems, but the scientific part is not following the whole process for risk. And these are not always sort of conservation strategies, but they are strategies to show the public what's happening. So I do think that we need to see these issues as critical and to be discussed in all translocation projects programs in Brazil. And of course, we are going to see many here that were successful projects and that these projects were very well studied, but we do have some other programs, other proposals throughout Brazil that do not go through all these details. And then we need to have this issue very well balanced out. And I think that the risk of not doing anything, it's definitely inherent, but the risks of doing something, sometimes they're underestimated. And I like to make that clear. We underestimate the risks of reintroduction in many cases, because you could be bringing some other species to an end, by introducing that species. So instead of helping biodiversity, you are risking the existing biodiversity in the area. So I'm going to try and approach some of this in my presentation, showing a little bit about the experience that we've got, in the sort of core central part in the Pantanal. But what I'd like to, the good thing is they need to be praised, but problems need to be balanced down. And as balanced as Carlos himself mentioned, are we going to release the species? Are we not? What are we taking? So, but I think that the presentations, they were very good, and we have a great base to start tomorrow, and also for us to continue our discussions today. So thank you all very much. Congratulations. Thank you. Fernanda, Rosanna, if you have anything else to add. Fernanda, you're on mute. I am sorry. No, I think that this discussion that we are engaging in is important. And I think, this is going to help this area. I agree with Barbanti, because we need to discuss these issues. In other words, risks, the benefits, and what can we do, the best way of doing it, how much can we do, and what is the best way of doing it. So yeah, thank you. Okay, everyone, look, thank you. Thank you, the three speakers. We did plan for a 15-minute break, but I'd like to know if 5 minutes is enough. Is that okay? And then we'll continue. For our presentation, we would start at 4:15, 7-minute break instead of 15. Is that okay, everyone? Okay, great stuff. So I'll see you all very soon.
Olá, todo mundo.
Oi, Mari, tudo
Oi,
bem? Tudo bem, Selene?
tudo bom?
Tudo jóia.
Yes, hello.
Para a gente ir voltando, dar aqui um sinal de vida.
Vamos, galera, vamos, galera, vamos, galera. Translocação de ungulados.
Até agora, uma melhor que a outra. Incrível.
Diferente mesmo.
One presentation better than the other up until now. I mean, that's really good.
Oi, Joe.
Hi, Joe.
Bom, deixa eu perguntar no chat.
Well, okay, let me ask on chat.
Se as pessoas estão nos ouvindo.
Can everyone hear us? Can we start then? Resume our activities.
Ok, então.
Okay.
Acho que o Marcelo que está compartilhando a tela. Tati.
I think it's Marcella who's sharing his screen. Okay, Tati, you're up. Can you
Bom, o nosso próximo
remove the sharing?
com os desafios e
So the
oportunidades
next block with the challenges and opportunities for the translocation of ungulates in Brazil. We're going to have Selena, and then we have Paolo Mangini, and then finally we have José Luis to bring this block to an end. As previously, I'm going to ask you to leave the questions, okay, for the end. If you want to write them down on the chat, leave a register, then we'll go through it, okay, when we reach the Q&A. So welcome, Celine. Introduce yourself to us. Okay, thank you, Mariela, for the invitation to take part. I am a professor of the State Santa Cruz University in Ilhéus. Bahia. I work with behavior. I am a biologist. I have a background in ethology, and I'm going to present to you a little bit of this work that we have been doing to try and develop pre-release protocols. So I'm going to share with you. Can you see? Yes, we can see your PowerPoint. So you have half an hour, okay? 5 minutes before the end, I'll let you know. Okay, so starting here, I have brought this paper, which is exploratory behavior stimulus in Day to target pre-release programs. So in this sort of scenario that Rodolfo presented to us, so well, where we have seen a lot of loss of fauna, loss of forest, we have seen that the animals have adapted to the environments within their sort of evolution process, throughout many years. And then with our urban expansion, with our interventions done on the environment, we have a completely different scenario today, a fragmented forest with many different corners as far as plantation is concerned. And we can see that animals are being challenged, behaviorally speaking, to find shelter, to find areas of foraging. And this readaptation means that they need to be challenged to develop new behaviors to face this new scenario. So in this whole sort of readaptation process, ethology, we have been working to try and understand what are the best indicators that could denote, if you will, the hindering of the well-being of these animals. A lot of the times we talk about sort of well-being observation in captivity only, but in recent years we have been trying to acknowledge the hindering of this welfare of these animals in sort of wildlife, free life. But I'm going to explain a little bit about this theory, which is governing this sort of whole body of knowledge, if you will. So we have a quadrant here that shows the environment. And this environment can make the animal have a pre-emotional disposition to certain types of behavior expressions. So we have an environment which is going to motivate the animal in what we refer to as a positive valence. So we can have a animal which is in a good sort of welfare condition. So they have all conditions, food, foraging conditions, sheltering needs, they're all provided for. So here we can infer certain emotions for this animal, okay? And in the theory that comes from humans, we are capturing the sort of human theory and we are developing paradigms to test the effect of the environment in the animal's sort of emotions. And then in this sort of positive valence quadrant, let's say that the animal is doing well, they can show behaviors of reinforcement of, approximating to the stimulus that they want, and they can feel excited, they can feel happy in this environment. The animal can also be fine, but they could be relaxed, it could be calm. And this shows body stability, which is a little bit less as far as body movement is concerned. On the other side of this sort of quadrant, we have the opposite, okay, which is the sort of negative valence. They're going to be fearful, higher level of anxiety with the body moving more, but the animal is in a negative sort of condition as far as its emotion, welfare. And in the sort of a lower part of the quadrant, they could be sad, they could be depressed. And then the sort of body movement is also smaller. So within this emotional context, we have this theory which is being developed to be able to address this emotional effect of animals. And here we have a cognitive bias sort of paradigm and judgment bias paradigm, which translates from human theory that a sort of half full glass could be seen as a full glass of water by an animal that is doing well. And this is something that we see in humans, and we are showing that animals can also show when they're not well, that a sort of half-filled glass with water is actually an empty glass to them, So within this context, of hindered, compromised, fair, we did tests of the white-lipped peccary to analyze the effect of hunting on these animals. And then in this paper, we have seen that an emotional state, when it is hindered, when it is compromised, it hinders the animal's decision-making process, which again is very damaging for its survival in the wildlife, So we tested this in laboratories, and this is possible for us to train using the sort of classical conditioning with the white-lipped peccaries, okay? Do not be at all surprised by this graph, okay? But what does it say, okay? Well, the cognitive bias training you train a positive sort of signal with the animal, the go, no go. So you give it a task for it to go to have some food, and then you train a signal which is associated to this animal coming to eat this food. So you have the go signal, and then you also train another sort of sound signal for the animal not to come, and then they learn really fast. I mean, the white-lipped peccary, they're actually very smart animals. In 3 days you're able to condition, okay, these animals. They're very, very smart. So we did this, and then we tested with an ambiguous signal, which is a signal they've not been trained for. And the idea, okay, of this cognitive bias paradigm is to try and establish what sends this ambiguous signal to the animal. Because if we use the theory from humans, for example, if they're doing well, if they're feeling okay, they're going to have a more positive interpretation of that signal. If they are not doing that well emotionally, they can interpret this negatively. And here, in the control state, so treatment, we see that females, which is this sort of blank histogram bar, is that the females are more positive in interpreting the signals than males, okay? But both do not react as a positive signal. And then we did this test, which would be the control. We did this test simulating a hunt. So we captured the animals using a net, for example, and then we used the same test to see the example of the simulated hunt with these animals. And then here you can see that, males and females reacted in the same way as if it was a negative signal. And unfortunately, each stage lasted 7 days, only, and then 7 days after, these animals, they start going back to normal. So there's any other sort of control treatment group. But I've only brought this to you to show how much animals may be affected by these changes to the environment, such as, the hunting effect or other environments where they're being threatened with, noise, and how this can really, really have an effect on the animals' well-being, which is going to affect their decision making. And this could partially explain why certain specific populations go into decline, be in the medium, in the short, or in the long term, how this emotion may have an effect on the decline of the population. And then here, what I want to tell you is, is related to the translocation, the types of translocation that Rosanna addressed so well. So I don't really need to go into detail here, because this has also been explained. Then we have like a pre-release training, which is something that I've been doing with the animals. So I've been training, the animals. I've got another example of the white-lipped peccary. But what are the assumptions that need to be taken into account for this training, for this translocation and this pre-release training? So for reintroduction, we need to check whether these animals are candidates for pre-release, if they are, from populations that are of a surplus in captivity, so they need to be in good health. The status of the environment of where they're going, they need to be in a good conservation state to get these animals, their behaviors, skills, abilities. They need to correspond to the needs that they're going to have. For instance, foraging, looking for food, exploration, and their sort of defense behavior against predators.
So based on these questions, we have been working on environmental enriching to strengthen these behaviors in peccaries and other species. So when we talk about environmental enriching, there is a theory behind that, and this cannot be freely interpreted as some think. There is a rationale to understand if that environment enrichment is beneficial to the species. It needs to be tested, analyzed, replanted if necessary. And this works with the predictability or the unpredictability. So a captivity environment is predictable. The animal has control over it. So when you introduce objects and stimuli, you make the environment unpredictable. And some authors consider unpredictability as detrimental to the animal, depending on how it is introduced. But other authors have tested or have made hypotheses regarding signaled unpredictability. In other words, the animal has control over the environment. He knows where he's going, the routes of escape when they need. That's important, but unpredictability is important for the animal to not fall into depression. So Gilbert Norton and Waters have talked about signaled unpredictability. They hadn't tested that yet, and we did that with the white-tipped peccaries. If the animal has control over their environment, this is good. But a small amount of unpredictability, if the animal knows that this will not remove the certainties that it has, for instance, food supply, can be beneficial. So we tested that with a white-lipped peccary, introducing some unpredictability and testing signal as well as unsignaled unpredictability based on classic conditioning. The aim was to introduce some predictability in order to decrease agonistic behavior, because we were talking about a captivity environment, increase exploratory behavior, and reduce inactivity. So we analyzed this enrichment by looking at these behaviors. And to do that, we built a feeder, a type of feeder. We did that in our lab in a semi-captivity environment, a 100 square meters area for the peccaries. So we analyzed 12 animals there by building a feeder, which we call a challenge feeder. This is a traditional feeder, which is a truck tire cut in half. And that's where they get their food from. And these other feeders, we tested them by building a small door. We installed them around the fence poles, and we would fill only 4 of them with feed. So to introduce spatial and temporal unpredictability, what we did is during the enrichment period, these 4 feeders with food, they were placed randomly before they were opened for the animals. they would fill them randomly, these 4 feeders, at different times and places. So every feeding time, the animals would have to look for the food. So we had 1 feeder for 3 animals. We made observations in twice a day, in the morning and afternoon. Every animal was observed during these periods, during 60 minutes, and every experimental phase lasted 10 days. So we used the Hefner paradigm, which is ABA. So C1 was A, control 1, feeding routine. U is unpredictability, unpredictable. Then again, a second control, a second unpredictable moment, and the third control. So U1, which was space and time unpredictability, was unsignaled. They had no signal that the food was coming. And the second unpredictability element was after spatial and temporal. It was signaled with a whistle announcing the food. So every experiment lasted 10 days, and the results are as follows. The most inactive behavior of animals, there was a difference in unpredictability 1 as well as on control 2. In those moments, there was a decrease in the exploratory moments or behavior. Aggressiveness was seen only in the first enrichment, in the first stage of the enrichment. This was explained in the study because the animals were learning how to get food from the feeder. So after they understood, aggressiveness went down, and in the following stages, it wasn't really observed. And the exploratory behavior, which we wanted to increase, this goal was achieved. Both in the first and in the second moment, we had an increase of the exploratory behavior. And what really drew our attention was that in the second enrichment phase, the animals, the exploratory behavior lasted longer. Males, they tend to explore more than females, both in the first and the second enrichment phases. And that motivated us with regards to the signal effect, because it's a type of control. This would make the animals stay longer in exploratory behavior mode. This can be explained by the increase of confidence in animals, oxytocin and other hormones that make them extend their exploratory behavior. Another effect was no body weight change. Even though the feeders were scattered around the area, they would get their food supply and their body weight didn't change. So that made it safe for these feeders to be used as a feeding tool. So the colored peccary, the unpredictability training was successful for this species, and the signaled unpredictability made the behavior last longer. And we believe that can facilitate the release of these animals. increasing the chances of these animals to find food, to search longer for food and for foraging areas. Right now, we have some plans to test this effect. I have a doctorate and a master's student, and we are working on a program, on a training program for these animals that will be released. We have 10 animals that will be reintroduced in the Eunápolis Reserve that is next to the Pau Brasil Reserve, and they will be tested in a release environment. We're also validating the method of testing the specimen's personality and the physiological parameters. This will make it easier to train them because we know that both types of peccaries, they have different individual behaviors. So once we validate the physiologies, we can know if one animal is more fragile than the other. We can assist them in a individualized manner or a more tailored manner. Once again, thank you very much for your attention and for the invitation to speak.
Muito obrigada, Selene.
Thank you, Selene. You were very concise. Thank you. And it's good because we'll have more time for Q&A and comments afterwards. Thank you for showing these behavioral aspects that are so important. Now I would like to call Paulo. Do you want to share your screen? Yes, I can do that. I made some last minute changes, so I think it's better for me to share the screen. If it doesn't work, I'll ask you to do it. Thank you. So thank you, Paulo. Go ahead. Can you see my presentation? Okay, thank you. Hi, I'm Paulo Mangini. I'm a veterinarian, and I work with several fauna management issues and fauna health issues. And it's a pleasure to see some familiar faces and names as well. We hadn't met for a while. Gonzalo asked me to talk about diseases, so I tried to set up a presentation regarding infectious diseases, risk factors, epidemic risk factors, and not only infectious diseases, but I tried to show a little bit of what diseases mean when we talk about refaunation and reintroduction of species, to understand how they can be a problem and when they're not a problem. When we think about translocation and reintroduction, there are three assumptions regarding diseases. First, that there is an environment to where the species will be introduced. They need to have good conditions, resources, space, and environmental quality. When we talk about ungulates, we know that these requirements are even more important. And the second aspect is that there should be good epidemiological conditions for the species, for the individuals that will be introduced, and for the species that are already there and that will interact with them in terms of diseases and in terms of population strengthening, that the individuals that are already present are epidemiologically compatible to avoid the risks for the population that is arriving and the already present population. So the environmental conditions, as well as epidemiological balance, and for the introduced and the already existing populations, have to do more with the landscapes that you're working on than the ecosystems. Why am I saying that? Because you can think about a bundle of diseases for the Atlantic forest, the Pantanal, the Amazon, but that's not how it's done. For every landscape, more or less fragmented, we need to think about a specific situation and whether it is relevant or not in terms of risks regarding pathogens when performing translocation. We will use peccaries, the white-lipped peccary, as an example, but it's only an example. When we talk about diseases, there are factors that need to be assessed, and we will use the white-lipped peccary to show you that. When we talk about reintroduction and population strengthening, we are talking about populational viability, basically, and the relation of that species with the system and how that lasts throughout time. When we think about diseases, I think about, for example, prey and predators, because one species regulates the other in ecological terms, and diseases work in the same manner depending on how they interact with the species. The pathogens, I mean, the pathogens themselves can interact with the species and control the population, making them more or less viable. And how does that work? Well, you have a pathogen within the population, and it can lead to a disease. And so you can think about a sick animal, and you don't necessarily need to introduce a disease. The pathogen can be there, and they can only alter the balance between gains and losses in the population, for that population and other populations. It can basically be a pathogen that doesn't lead to disease, but that reduces the survival of that individual in time, which increases mortality and impacts the population in the future. The pathogen can also increase the immunity resistance of that individual. It can also reduce the reproduction rate of a certain species, and at the end, the result will be the same: more losses and less efficient populational gain than the natural loss of population. So this is both for the reintroduced species as for the species that are already there. Also, these species can become a repository of pathogens, and they can suffer influences when that pathogen is present. So when you understand this relation as losses and gains, it makes it easier. The pathogens, they can either kill the organism that we want to survive or reduce their viability in time. So these are the ways that pathogens can affect different populations. I think that we already talked about this today. It has to do with the risk or the lack of risk or the loss of ecological functions within a system. What should we prioritize? Well, this is never easy